Okay, good evening students. In the last class we completed about the problems on Henry's law. Okay, in the last class we solved some numerical problems related to Henry's law. Today we shall start the new concept in this solutions lesson. Okay, today we are going to start the topic of vapor pressure. So what do you mean by this vapor pressure? What do you mean by this vapor pressure? First of all, we shall learn what do you mean by this vapor pressure. Vapor pressure means, okay, in order to understand about the vapor pressure, let us take certain amount of liquid. Let us take certain amount of liquid in a closed vessel. Let us take certain amount of liquid in a closed vessel. Due to the process of evaporation, evaporation means what happening? Okay, due to the process of evaporation means okay, the surface molecules when they are gaining sufficient amount of energy, they can overcome this intermolecular force of attraction. They can overcome the intermolecular force of attraction and escape from which state to which state, means the liquid state to vapor state. This is called as the evaporation. For evaporation, any heating is not required. So evaporation means nothing but when the surface molecules are gaining sufficient amount of energy. Okay, because you know that the molecules energy is changing continuously. Okay, when the surface molecules are gaining sufficient amount of energy, with that higher amount of energy, they can overcome this intermolecular force of attraction, and they will escape from liquid state to vapor state. This phenomenon is called as what? Means evaporation. We have to call, what we should call means evaporation. Due to evaporation here, certain quantity of liquid, what happens means decreases. You can observe there is a certain decrease in the quantity of liquid. And here some amount of vapors are formed. What are formed means some amount of vapors are formed. And one more process is taking place here. This process, liquid converting into vapor, is called as evaporation. And one more process is happening here. What is one more process happening here means the vapors condenses themselves. And convert back into liquid. This process is called as the condensation. We have to call. Here two things are happening. One is evaporation and the next one is what means condensation. Evaporation means surface liquid molecule converting into vapor state is called as evaporation. And these vapors condense themselves and convert back into liquid. This is called as condensation. Okay, if you observe after certain period of time, if you are observing this closed vessel, there is okay up to certain time the amount of liquid is gradually decreasing and amount of vapors is continuously what happening means increasing. But after a certain point of time, okay, there is no more change in the level of liquid and there is no more change in the amount of vapors. After a certain period of time, you can observe there is no more change in the level of liquid and there is no more change in the amount of vapors. Why? Because means after certain point of time, here equilibrium has been formed. What has been formed means equilibrium has been formed between these two processes, between evaporation process and condensation process. What has been formed here means equilibrium has been formed. After the formation of equilibrium, now what do you mean by this vapor pressure means? Vapor pressure means nothing but the pressure exerted by vapors of a liquid, when these vapors are in equilibrium with the liquid. The pressure exerted by vapors of a liquid when these vapors are in equilibrium with liquid is called as what? Means vapor pressure. We have to call is called as what? Means vapor pressure. The pressure exerted by vapors of a liquid only when these vapors are in equilibrium with liquid is called as what? Means vapor pressure. We are calling as what? Means vapor pressure. Okay, the vapor pressure is mainly depending upon some factors. The vapor pressure of a solvent is mainly depending upon some factors. What are the factors affecting the vapor pressure value means? Mainly we can say nature of solvent, the amount of vapor pressure is affected by certain conditions. The first fact, okay, a solvent is having more vapor pressure or less vapor pressure, we can explain it from some points. The first point is what we can say means some nature of solvent, nature of solvent. Okay. Here I taken here two solvents A and B. Here in case of A, intermolecular force of attraction is very less. But in case of B, I am taking here intermolecular force of attraction is very strong. In case of A, intermolecular force of attraction is very less. In case of B, intermolecular force of attraction is very strong. So among these two solutions, which solution will exhibit more vapor pressure? Which solution will have more vapor pressure means the solution in which intermolecular force of attraction is very less. Okay, that in that case, this surface liquid molecules very easily they escape from liquid state to vapor state, because here intermolecular force of attraction is very less we can say. Okay, this is liquid molecules, this surface liquid molecules very easily they escape from liquid state to vapor state. Hence, we are getting here more vapor pressure. But in case of B, if we take here, intermolecular force of attraction is very strong. Intermolecular force of attraction is very strong. If intermolecular force of attraction is very strong, it is not easy for this surface liquid molecule to escape from liquid state to vapor state. So consequently, we are getting here lesser vapor pressure, and here we are getting what means more vapor pressure. So this is the first point we can say about the factors affecting vapor pressure. What are the factors affecting vapor pressure means? The first factor is nature of solvent. All solvents are not going to have the same amount of vapor pressure. Whether a solvent is having more vapor pressure or less vapor pressure, it depends upon the type of the solvent. Those solvents in which intermolecular force of attraction, is very weak. Okay, in that solvents, the surface molecules very easily they escape from liquid state to vapor state, and consequently they are having higher vapor pressure. But these solvents in which intermolecular force of attraction is very strong, the surface molecules cannot easily escape from liquid state to vapor state. Hence, in this case, vapor pressure observed is very less. Okay, this is the first point we can say. So, this is, since A is having, I said A is having less intermolecular force of attraction, that's why vapor pressure of A is greater than that of what means vapor pressure of B. It is the first factor affecting what means vapor pressure value. What is the second factor which is affecting vapor pressure value means the temperature. The second factor which is affecting the vapor pressure value is what means temperature. Temperature we can say. Suppose if you kept two liquids at you kept the same liquids, you kept the same type of liquid, it is also a liquid and it is also a liquid, but I am keeping it two different temperatures. Here the temperature maintained, suppose for example 30 degrees, here temperature maintained is for example 50 degrees. In which case you are going to get more vapor pressure. In which case you are going to get more vapor pressure means when the liquid is kept at higher temperature, the liquid molecules are gaining, the surface liquid molecules are gaining more amount of energy. With that more amount of energy, they can easily overcome the force of attraction, hence they can easily escape from liquid state to vapor state. Here okay, since the liquid is maintained at less temperature, since the liquid is present at less temperature, the energy gained by surface molecules is also less. With that less energy, it may not overcome the intermolecular force of attraction. But here the liquid is maintained at high temperature. Since the liquid is maintained at high temperature, the surface liquid molecules are gaining more amount of energy. The surface liquid molecules are gaining more amount of energy. With that higher amount of energy, they easily escape from liquid state to vapor state. Hence they are having what means more vapor pressure. Hence we can say the relationship that temperature is directly proportional to vapor pressure. Temperature is directly proportional to vapor pressure. Here which solution is exhibiting more vapor pressure means the solution which is kept at higher temperature, it is exhibiting more vapor pressure. It is exhibiting more vapor pressure. Okay, this is the next concept in our solutions lesson, vapor pressure. So what is vapor pressure? I have understand, I think. So what is vapor pressure means the pressure exerted by the vapors of a liquid. The pressure exerted by the vapors of a liquid when these vapors are in equilibrium with the liquid. The pressure exerted by vapors of a liquid when these vapors are in equilibrium with the liquid is known as what means vapor pressure. We have to call it as what means vapor pressure. Next, vapor pressure is mainly affecting on mainly depending upon two factors. The first factor is nature of solvent. Okay, the solvents in which intermolecular force of attraction is very less, generally those kind of solvents, they can easily convert into vapor state. Hence they are having more vapor pressure. And we can say the next factor is what means temperature. Temperature is directly proportional to vapor pressure. When temperature is increasing, vapor pressure of substance also what happening means increasing, we can say. The next thing we can discuss here about the so in the solubility case also, we discussed solubility in two kind of solutions. What are the two kind of solutions we have discussed? The solubility means solubility of solid in liquid type of solution and solubility of gas in liquid type of solution. We have discussed the concept of solubility in two types of solution. In the similar manner, vapor pressure concept also we are discussing in two kind of solutions. What are the two kind of solutions we are discussing? This vapor pressure concept means vapor pressure of liquid in liquid type of solution, and the next one is vapor pressure of solid in liquid type of solution. Okay, in today's class we shall mainly focus on vapor pressure of liquid in liquid type of solution. Students, mainly remember that in solution lesson, all liquids we have to consider as a volatile substances. Volatile substances means they can easily convert from liquid state to vapor state, and all solids you have to consider them as a non-volatile substances. They are not converting from, okay, they are not easily converted to vapor state. Non-volatile means they are not easily converted into vapor state, but volatile substances means they are easily converted into which state means vapor state. In this solutions lesson, we have to believe that all liquids are generally volatile in nature, and all solids you have to consider them as what means non-volatile substances. We have to consider in this lesson of what means solution. Now I am discussing here vapor pressure of which type of solutions means liquid in liquid type of solution. Here liquid in liquid type of solution means the solution is having two components. Both the components are present in liquid state only. Since both the components are present in liquid state, we can say that both the components are volatile in nature. Okay, this A component also converting into vapor state as well as B component also converting into vapor state. Okay, here the vapors formed here, it contains both the components in each. Okay, it contains A component as well as the B component also. Since A is also volatile in nature, it is also converting into vapor state. B is also volatile in nature, it is also getting converted into vapor state. Okay, since both are volatile components, we are having both the vapors in this, both the components in the vapor, both the components in this vapor. Now we can study about here one important law called as the Raoult's law we can study. Now we are going to study here one important law called as what means Raoult's law. What is Raoult's law? We can say means among this total vapor pressure, the pressure shown only by the vapors of A, the pressure shown only by the vapors of A is to be called as what means partial pressure of A. The pressure shown only by the vapors of B is known as what means partial pressure of B. The pressure shown only by vapors of A is known as partial pressure of A. The pressure shown only by the vapors of B is to be known as what means partial pressure of B. So the Raoult's law, the scientist Raoult, he observed a relationship between this partial vapor pressure and mole fraction of the component. He observed the relationship between partial vapor pressure and mole fraction of the component in the mole fraction of component in the solution, and he formed one law. That law is called as what means the Raoult's law we should call. That law is to be called as what means Raoult's law. According to Raoult's law, the partial vapor pressure of a component is directly proportional to mole fraction of the component present in the solution. According to Raoult's law, the partial vapor pressure of a component is directly proportional to mole fraction of component present in the solution. So if you remove this proportionality constant, what we are going to get here means PA is equal to PA naught into XA. What we are going to get here means PA is equal to PA naught into XA. Next, in the same manner, partial pressure of B is directly proportional to mole fraction of B. Partial pressure of B is directly proportional to mole fraction of B, and if we remove this proportionality constant, PB is equal to PB naught into XB. PB is equal to PB naught into XB. Now I want to get the total pressure. How can I get the total pressure? Total pressure means we have to add the partial pressures of A as well as what B. So total pressure PT is equal to PA plus PB. Total pressure PT is equal to PA plus PB. Here PA means what we got, PA naught into XA. PB means what we got, PB naught into XB. We can substitute in the formula. PT is equal to what we are getting here means PA naught into XA plus PB naught into XB. PT is equal to PA naught into XA plus PB naught into XB. Is the first formula we got here. Okay, this is the first formula we got here. Total pressure PT is equal to PA naught into XA plus PB naught into XB. Here I think explained you what is PA naught here means vapor pressure of the substance in pure form. PA naught is a constant vapor pressure of the substance in pure form. PB naught is a constant vapor pressure of the substance in pure form. Here vapor pressure of substance A in pure form, we have to call it as PA naught. Vapor pressure of substance B in pure form, we have to take it as what means PB naught we should take. Okay, here this is the first formula we got here. Total pressure PT is equal to PA naught into XA plus PB naught into XB. Next thing, okay, we know that according to mole fraction, the sum of mole fractions of all the components present in the solution always equal to 1. The sum of mole fractions of all the components present in the solution is always equal to how much means 1. Now in the solution how many components are there means 2 components are there. So sum of mole fraction of A plus mole fraction of B is equal to how much we are getting? 1 we are getting. Mole fraction of A plus mole fraction of B, how much we are getting means 1 we are getting. So mole fraction of A is equal to send this XB that side, what we are going to get means 1 minus XB we are going to get. What we are going to get here? 1 minus XB. Substitute this value in the formula. Means what we are going to get? PT is equal to PA naught into XA plus PB naught into, okay, in the place of XA we can write it, okay. In the place of XA what we can write means 1 minus XB we can write 1 minus XB plus PB naught into XB, So PT is equal to PA naught into 1, that is nothing but PA naught minus PA naught into XB plus PB naught into XB. From these two terms, what we can take it common here means XB we can take it as common, and PT is equal to PA naught plus XB into PB naught minus PA naught. Okay, this is one more formula we got it for what means Raoult's law. This is the one more formula we got it for what means Raoult's law. This formula we can also write in another manner also. What is another manner we can write this formula means PT is equal to PB naught plus XA into PA naught minus PB naught. In this way also we can write the formula. Okay, we taken here XA is equal to 1 minus XB. We can also take XB is equal to what, 1 minus XA. If we take XB equal to 1 minus XA and if we substitute in the formula, we are going to get this formula. So both the formulas are correct for this Raoult's law. Okay, these are the totally 3 formulas we are getting the Raoult's law here for liquid in liquid type of solution. First formula is PT is equal to PA naught into XA plus PB naught into XB. Second formula PT is equal to PA naught plus XB into PB naught minus PA naught. And third formula is PT is equal to PB naught plus XA into PA naught minus PB naught. These are the formulas we are getting for what means Raoult's law. Next thing. Next thing you can see students here. Here XA and XB means the composition of substances in which phase means liquid phase. XA and XB refers to the composition of substances in which phase means liquid phase. Okay. So in vapor phase also we can find the composition. Even in which phase also means vapor phase also. We can find the composition even in which phase also means vapor phase also. Okay. So in vapor phase, the composition in vapor phase. My XA and XB means what? A composition of A and B in which phase means liquid phase. That is an XA and XB composition of A and B in liquid phase. A and B they are present in liquid phase as well as they are present in vapor phase also. Composition of A and B in vapor phase, how to find it? That's what we are discussing here. For finding the composition of A and B in vapor phase, we have to apply the Dalton's law formula. What is the Dalton's law formula we are having means Dalton's law is equal to, according to Dalton's law, partial pressure is equal to total pressure into mole fraction. It is the formula we are having for Dalton's law. What is the Dalton's law formula we are having means partial pressure equal to total pressure into mole fraction. Here I am in vapor phase. Okay, in order to differentiate between the liquid phase and vapor phase. In vapor phase composition, in vapor phase mole fraction, I am taking it which letter means Y I am taking. I am taking it which letter means Y. PA is equal to PT into Y of A I am writing. What I am writing means Y of A. PA is equal to PT into Y of A. Okay, Y ಎದಕ್ಕೆ ನಾನು Y ಅಂತ ಬರ್ತಾ ಇದಂದರೆ ಓಕೆ ಲಿಕ್ವಿಡ್ ಫೇಸ್ದಾಗ ನಾವು ಹೆಂಗೂ ಎಕ್ಸ್ ಅಂತ ಬರ್ತಾ ಇದ್ವಿ ಮತ್ತು ನಾವು ಇಲ್ಲಿನೂ ಎಕ್ಸ್ ಅಂತ ಬರ್ತಿದ್ರೆ ನಿಮ್ಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ. ಲಿಕ್ವಿಡ್ ಫೇಸ್ ವ್ಯಾಪರ್ ಫೇಸ್ ಅಂತ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ. ಆ ಕನ್ಫ್ಯೂಷನ್ ಕ್ಲಿಯರ್ ಮಾಡಲಿಕ್ಕೆ ಇನ್ ವ್ಯಾಪರ್ ಫೇಸ್ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ವಿ ಆರ್ ಡಿನೋಟಿಂಗ್ ವಿತ್ ವಿಚ್ ಸಿಂಬಲ್ ಮೀನ್ಸ್ ವೈ ವಿ ಆರ್ ಡಿನೋಟಿಂಗ್. ಹ್ಯಾನ್ಸ್ ವೈ ಎ ಕಾಂಪೋಸಿಷನ್ ನಾವು ಹೆಂಗೆ ಕಂಡುಹಿಡಬೇಕು, ವೈ ಎ ಆ್ಯಂಡ್ ವೈ ಬಿ ವ್ಯಾಲ್ಯೂಸ್ ಕಂಡುಹಿಡಬೇಕು. ಸೊ ವೈ ಎ ಈಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಹಿಯರ್ ಮೀನ್ಸ್ PA divided by PT. PA divided by PT. And you know, according to Raoult's law, PA andre formula enama PA is equal to PA naught into XA. PA is equal to PA naught into XA divided by what means PT. Okay, in this way we can find out the composition in which phase means vapor phase. Composition of A in which phase means vapor phase. In the same way, YB is equal to PB divided by PT. PB is equal to PB naught into XB. PB naught into XB divided by what means PT. PB naught into XB divided by what means PT we can say. So this is about the composition of A and B. Composition of A and B in which phase means vapor phase we can say. Which phase? Vapor phase. And finally I want to explain you one graph here you can see. I want to explain you about one graph you can see here. From here to here, on x-axis we taken here mole fraction, on y-axis we taken here vapor pressure. On y-axis we taken here vapor pressure and x-axis we taken here what means mole fraction. From here to here mole fraction is constantly what happening means decreasing. Mole fraction of A constantly what happening decreasing. Okay, I am writing here this one also. So now explaining the curve with respect to A. From this point to this point, mole fraction of A constantly what happening means decreasing. Mole fraction decreasing means vapor pressure also what happens decreases. Mole fraction decreases means vapor pressure also decreases. So this curve belongs to which component means A. And this curve you can see xb equal to 0, xb equal to 1, xb equal to 0, xb equal to 1. From here to here mole fraction is what happening means increasing. Mole fraction is increasing means vapor pressure also increases. So this curve belongs to which component means B. B you can see here from here to here B mole fraction is increasing. So vapor pressure also what happens means increases we can say. Okay, next this point you can see at this point. Okay, only A is present, B is totally absent. So this point you have to consider as what means the PA naught we should consider. This point is to be considered as PA naught. At this point you can see here only B is present, A is totally 0. This point you can consider as what means PB naught. This point you should consider as what means PB naught. Okay. At any point in the middle, both A as well as B is present. Both A as well as B is present. And so at any point in the middle, we can write PT is equal to what means PA plus PB we can write. PT is equal to what means PA plus PB. So this is the graph we are getting for vapor pressure of liquid in liquid type of solutions. You may have doubts, sir, why you written A downside and why you written B downside, B upside means you can write it anywhere, no problem. If you write it like this, we can understand vapor pressure of B is more when compared to vapor pressure of A. That means B is more volatile in nature when compared to A. You can write it anywhere, no problem is there. Okay, thank you.